Right, sample problem 2. 3 identical resistors connected in star across a 3-phase 550 volt line, dissipating a total active power of 3000 watts. We're going to calculate the current in each line, the value of each resistance, and then we're going to look at the total power dissipated if the same load was connected in delta. Yeah, which we can do once we know the values of the resistors. So, we've been given the total power here in watts because they are resistors, they're per resistance. So we haven't got any complex powers involved here. There's no Q, and therefore P and S will be equal to each other and in phase with each other. So there ain't no triangle with this problem in that sense. Alright, we're talking per resistance. So, the question first of all is asking what the current is in the line. How are we going to tackle that? Yeah, say that again, Alan. ST is 3 IP Yep. Yeah, and in this question we can actually say, we could say that that's P, can't we? Yeah, because they're resistors and there ain't no complex parts. What would you prefer me leave it as, S or go with P here? All your formulas are S, aren't they? Let's keep it to S. That links it in. Yeah. We're going to rearrange, so we'll rearrange that for IP. That must be ST over 3EL, agree? It's not. We're not in delta. You give me that one. I actually want either that one or that one. In my notes, I've actually used this one, but either of those two will do, but any of them won't. See how these two are the same, but those two are different. You've got to be careful. Okay? That therefore explains that for the same load, those two aren't equal. Yeah? Alright? So going back to the problem, this should be get rid of all that, I think. Start again. Right, Alan, give me the right equation this time. Bearing in mind that you know EL and you know ST. as root 3 EL times and if you remember that one, that works for both systems, doesn't it? Yeah? Which is root 3 times 550. Oh, hang on, we want to rearrange it, don't we? That rearranges to IL as equal to ST over root 3 EL. That is 3000 over root 3 times 550 equals 3.15 amps. Yep. So the next bit, looking at that diagram, how are we going to find the value of those resistors? We now know that this is 3.15 amps in here. So what we want to do is focus on one resistor. That way we can find the value of it. So we're going to use Ohm's law, yeah. By Ohm's law, which E, Luke? We need that E. What's the terminology we're using for that E? This is EL, but that resistor's not seeing 550 volts, is it? It's only seeing that bit. That's the phase voltage. Yeah? So, by Ohm's law, R is equal to E phase over I line, yeah, because I line and I phase in a star connected system are the same. Yep. What can we rewrite E phase as? Can I break that as our I phase in there for a minute? We can rewrite I phase in a star connected system as I line. What can we rewrite E phase as in terms of E line, which what we know? That's E line over root 3. Yeah, so we're substituting in that. So that equals 550 over root 3 all divided by 3.15. And this subbing in here of the full value means you don't do a rounded voltage calculation and then put it in and round again. So there's a good reason for doing that. What do we get for that? 100.8, we'll round that, three significant figures, to 101 ohms. Yep. So that's A and B. This 3000 watt star connected resistive load connected to 550 volts. gives us a current of 3.15 amps. The resistance of the loads are 101 ohms. Yep. What we can do now is look at the third part of the problem. What's the total power dissipated if we connect that same load in delta? And I'm going to add a slide to mine and just draw it out. So what we got now is these three resistors. (101 ohms each). And that's connected to a 550 volt line in delta. Find C, find ST in delta connection. That's what the question asked. IL, I phase, and I phase. Yep. What trap mustn't we fall into here? Yeah. Well, yeah, we're using the right formula. There's a trap I could see you could fall into here of using the IL from the Stark system. Don't fall into that trap. Yeah. You use the same mnemonic for it, IL. The danger in the pressure of an exam is that you use the 3.15 amps. And that, as you'll see in a minute, that won't be the case. How many in the previous system? Right, work out how many. We never worked out what E phase was, but work out E phase, because each resistor in this system has seen E phase, which is 550 over root 3. What is that value? 317 volts. Right, in star, each resistor's got 317 volts across it. In delta, how much voltage has each resistor got across it? In delta, how much voltage has each resistor got across it? What's the phase voltage in delta? Essentially the same as the line voltage. So each resistor in delta has got 550 volts. Yeah? So how are we going to find this power? We've got to find the current somehow, haven't we? We need at least one of the currents. We don't know any current at the moment, and until we find a current, we can't really find a power, can we? Yep. So we can do I phase is equal to E line over R. That's 550 over 101 equals 5.45 amps I made it. Yep. So they very much aren't the same. Yeah. And then we can use which formula? Alan, you're the key man on total power formulas. Three EL IP. So we're going 3 times 550 times our 5.45 equals VA equals 8985 watts. Yep. Considerable increase in power. Right.